Okay, I'm here at the Ital Design, and this is their concept car. And this concept car, not only does it look cool, but it uses Elaphe motors. And Elaphe is right here. So I wanted to talk to the Elaphe guys. And I'll see if we can find the Elaphe guys. Hello.
Hey, how are you?
Good. Hey, I found you guys. Elaphe, right?
Yes, that's
Where,
us.
where is the engineering guy?
The engineering guy is busy, but you can talk to Luca. I think that would be good.
Okay.
Hey, Luca.
All right. I'm here with Luca from Elaphe.
Yes. Hi.
Hey, so can you tell us about your new motor?
Sure. So right now what we've done is we've built the first high-performance in-wheel motor that can fit into front wheels of performance-oriented vehicles.
Okay, what do you mean by that?
So typically, putting very high power, high torque motors inside the front wheels of the cars was very difficult because such cars require a massive amount of braking power. And that usually means that the brakes have to be really huge. And that in a smaller rim, you could not actually fit a huge brake together with a very high power motor.
Okay.
What we've done is we've been able to fit that together. We're able to put a 400 millimeter track-worthy disc brake, conventional track-worthy disc brake, into a 21-inch rim with over 200 kilowatts of continuous power per wheel.
Okay.
That's the first.
And I see that. That's like that rotor is huge. Where is the stator and the motor in this thing?
So if you look at this black color here,
Uh-huh.
essentially that's this thickness is your full rotor and stator all together.
Okay.
That's it. So it's just a thin ring. You can imagine it's a donut.
Yeah. So basically, it's very similar to the motor that Donut Labs is saying. Because they have a motor like that.
In concept, all in-wheel motors are very similar. They have a big hole in the middle,
Yeah.
and just a motor at the how you say the circumference. But the difference is how you integrate that. So you have continuous power, but you also have a standard bearing, a standard brake, and no necessary changes to the suspension geometry. So you can put this on a car for a performance upgrade as a product. And usually what it meant previously is you had to do a lot of customizations on the chassis, on the platform. But this is a product that's intended to go on the car as is.
Okay. What is the weight of this?
So currently the projected weight of this product is 40 kilos. So
Okay.
you're getting a really, really high continuous power density. And that's just to start with. We will have follow-up products announced later this year
Okay.
that will basically twofold those ratings that this motor has.
Like it'll be even more power dense?
Yes, so
What are the technological advancements that you've made that make that possible?
it's mostly thermal management.
Okay, so the biggest problem is thermal management.
Thermal management is usually the biggest problem in all electric motors, especially when you go to high continuous powers and high torques, is because anytime you go there, you create more heat, and magnets are usually very, very, very sensitive to heat.
Oh, okay.
So the better you can take that heat out, the better your motor is going to be in efficiency, but also in performance.
Yes.
So we've been working hard for the last year and a half of perfecting the concept that can actually go on the track and drive like a sport car.
Okay, so my question is like, let's say that I want to use that on not a high performance car, but a regular car. Can you make it very, very light and small?
Yes, and I'm glad you asked that.
Yeah.
So actually, this is part of our strategy. So our long-term roadmap is focused on making sure that this is an entry technology. So this is what you can put in vehicles today and get them on the road. But what we do is, with this, we also develop the control side. So we're very big on how to control it. It's about 20 times faster than anything with a shaft.
Okay.
And that control is an enabler for reducing cost in future platforms.
What do you mean by control?
I mean by finding ways how to use the fact that you can control each wheel very, very rapidly, unparalleled rapidly, and then you can control the vehicle itself and its dynamics. So 3D motion, lateral dynamics, all those things, and that means an even suspension, and that means that we can actually take out hardware from the original cars, from future platforms, make it cheaper, and still achieve the same functions or even better functions by only using the powertrain and software.
Okay, all right. So, like, let's say, like, what do you expect? Like, so you said this thing is 200 horsepower?
It's 350.
350 horsepower. Let's say you wanted like a 50 horsepower. What would the weight of that be, do you think?
So what we're looking at is in the future, so the technology is scalable, but not all design concepts are relevant for all the segments of the cars.
Okay.
This is high performance. It means it has some solutions inside that are different than what's going to go into a 50 kilowatt motor, let's say a 50 horsepower motor. That will be more oriented towards cost optimization rather than performance.
Okay.
However, from the weight perspective, I'm expecting for a 50 horsepower well below 20 kilos.
Okay. All right. And then we know that, like, I run a channel about Aptera, and Aptera was using Elaphe motors, and that was the thought process. And everyone was disappointed when they moved away from Elaphe motors. Do you know why they moved away from Elaphe motors?
So you have to ask them that.
Okay.
In my opinion, it's a business decision.
Okay.
So at Elaphe, we are ready and we were ready. You've seen the motors, the new Aptera motors. They were there. We measured the efficiencies. We were getting less than 100 watt hours per mile from an energy standpoint. So that's the question. We are still working with Aptera on powering their third wheel, which is coming later. So
okay,
no
very
worries
good.
about that.
Do you guys have a manufacturing plant?
So we have a low volume manufacturing plant.
Okay,
yes.
but you don't have a high volume.
We don't have a high volume manufacturing plant, yes, because it's a chicken or the egg thing.
Right.
So, but
you need funding to get the.
We need funding, but it's not. The money is not the issue necessarily.
Okay.
It's someone to take all those parts.
I see. You need someone to commit and give you the money to buy the parts. Then you'll build the high volume place.
Exactly. We have all the processes in place.
Okay.
Everything we know how to build it. We know the costs of that. The only important thing is you need to have someone that is able to absorb all those parts and put them on the road. And that's why we're also working with about 9 to 10 really super OEMs on their future platforms.
None of those. You guys don't have a high volume part out yet.
No.
Okay, but you're hoping that there will be one in the near future.
We are sure there will be one.
Okay.
In the near future.
Like in the next year, are we going to see an Elaphe motor?
We're talking about next 3 years, 3 to 4 years.
Okay.
However, this baby is in low volume production and it's coming out later this year for select customers.
Oh, okay. And are you selling this to OEM customers or people who want to modify their cars?
Primarily now to OEM customers.
Okay.
But when it comes to, let's say, supercars, low volume niche cars, there's a lot of different players, vehicle makers or integrators that we're catering to.
Okay. All right. Thank you very much, Luca.
It was my pleasure. Thank you for visiting.
Bye.